Okay, hey, for those of you watching this, I'm not sure what happened, but we Zoom just kind of decided it was done and we were not. So this kind of got unceremoniously booted from our own meeting. But we're back, okay, midstream. So anyway, yeah, okay, so here's the problem that we're going to be working today. And in a moment, and folks in the room already have some thoughts, which is great. That's what I'm wanting, what I'm hoping for. Um, so let's talk through this and then let me put that away. Let's talk through this problem. Let's talk sort of generalized approach. And then I actually want to give you guys last time I kind of ran with it immediately. This time I kind of want to give you a little bit of time to try to work through it. All right. So we're doing problem number 9, palindrome number. So given an integer, return true if X is a palindrome or false if otherwise. All right, so a palindrome is a fully symmetrical thing, right? Read either way, it's symmetrical. So for instance, input, if the input is 121, right, that's true. Left to right, it reads the same. Example 2, negative, obviously is not, because the whole negative thing there, and 10 is false. Okay, we look at the constraints. So this just sort of shows us the maximum size of that. So we're looking at sort of potentially pretty large numbers, and so our thing may need to handle that, but we'll see if that becomes an issue when we submit. All right, and then you're throwing this in a class, you're given your function here, define is palindrome. It takes in a single input X and outputs a Boolean. And by the way, just a quick reminder, if you're logging in, make sure your code, because again, you can do this problem in any number of coding languages, make sure it's set to Python 3. So from the drop down. And again, let me know if, yeah, okay. So okay, looks like many of us are back. Awesome. All right. So sounds like you guys already have some ideas. Let's talk about them. Raymond, you kicked us off. Let's talk. What are you thinking for this?
So I'm thinking of converting the integer into a string
Mm,
and then using a for loop where I would be 0 to, be the first index. And then it will be until it reaches the end of the length of the string. So as soon as the beginning of the string does not match the end of the string. So for example, if if index 0 does not match index -1, I'll return false and break the loop. And if not, if I could go through the whole for loop, I'll return true.
perfect.
I just need a program.
Yeah, no, I mean that's pretty much the structure I took.
Okay.
I think Karen, I don't know if you were thinking anything else.
It's redundancy to iterate through the entire string, so
Good.
you run range of length of string, integer division 2.
Yes, perfect. Okay. Did you pick up that nuance? So you want to do an integer division 2, right? Because the idea is you really, and I think you're sort of thinking along those lines. I think the refinement would have been there. But like if you're drawing, if you're drawing it out, right? Because you're going, if this is the whole thing, you're really just looking at this, that, and then this, that, this, that, this, that, this, that, and then you can ignore if it's an odd number, what's in the middle. So to this point, right, you're only making, n integer division 2 references. So you only need to loop that first set there and then make those comparisons, which I think is what you were getting at. That would have been the modification, because you don't need to keep looping because you've already gotten that. Okay, good. So that is a good constraint. So I think the trick with this, at least the way we're structuring it now, is really just kind of structuring those loops, right? So making those lookups.
Yeah.
So, all right, now, okay, sort of again, a few things to note, right? Best practices for this. Remember, when they're reviewing this, they're not seeing your thought process, they're not mind readers, not seeing that. They want to see you work the problem, which means do as much as you can on the screen, because that's what they see.
Yeah.
So, so write out comment out your approach, comment out your thing, work through your test cases. Don't do it outside of, don't have like a collab notebook or you're testing code fragments doing it. Like get into the habit of building out, like, testing the loops right now, building those things out, build them in there, test them and let them see you work through the process of debugging it. Because that's a big part of this. Because remember, there's nothing that stops somebody from just throwing the prompt into ChatGPT and getting a response. And again, one of the things we mentioned is that is a great part of practicing. Like when you are done, one of the things you should get in the habit of doing afterwards is just tossing it in there and seeing other approaches and learning from it. That is sort of a critical thing. But again, when you're taking it, they want to see the process. They want to see how the sausage is made. So, I want to say do it, but type out your approach, type out your assumptions, type out what you're going to try to do, type out each of the steps, work through those things. And that also, um, get used to sort of working on intermediate products, printing out sub processes, printing out those things, running those codes, testing those outputs. Again, that's what they want to see. Because the surest sign that this is an AI is just seeing you iteratively build and debug as you're going through it. Uh,
Always write out your pseudocode before you start coding, because if you don't finish, they'll be able to see that you've thought the logic.
exactly.
Another
Yeah.
question. Would it be a mark if, like, for example, because I have this problem where it's like, oh, I know I need to do a for loop, but for whatever reason, I'm like, how do I write a for loop? Is it wrong for me to go to Google during the technology and be like, hey, I don't remember how to do a for loop?
No, I don't. I mean, not to my knowledge. Again, I think, it's fine. I think realistically, like it's not like they're locking, it's not like they're locking your browser and preventing you from doing that. And like, if you need to look up, like, and that's happened to me, like I forget, like I'm like, oh wait, there's this method, like the one that we did last week. Like I forgot, I knew there was an enumerate, but I'd forgotten what it was. So I just Googled like, oh, what's the method for a list that gives you index and
Yeah.
I was like, oh, it's enumerate, right? So just Googling like that, heck yeah, like that's.
It also depends where. I took a test for LA City and they locked their browser.
Oh, interesting.
Yeah.
I haven't had a locked browser before, but that's interesting.
They
Okay.
literally you had to have permit, you had to use their specific like testing browser, you had to download and install. And it would detect what open programs. It would say, close WhatsApp, close Signal, close this, close that, close TeamViewer, and it would make you shut down all the programs.
Jesus.
Running in the background.
Okay, well,
Slack.
so listen, man, that may be.
When I took a HackerRank screen test, no, they didn't trip, but they would. I think they do have a way of detecting where you're going, where you're looking, So because I did do one, when I did a boot camp, they did do that exam where they would know what you were looking at. So you had to close like other tabs, but they didn't stop you from doing it, but they did want to see where you were looking.
Oh, interesting.
Yeah, because like I'm like a novice.
Yeah.
For lack of better words. So like basic stuff, I guess, I would have to like constantly search up.
Yeah.
I'm like learning that's fine.
I think again, I mean, it's gonna, as you heard, every test is gonna be different, everything's gonna be different. I think that's, I think for them, the big thing right now, I mean, knowing code by heart hasn't been ever since Google, like knowing every code by heart has not been, it's the old joke that like you'll be, 15 years in, you'll be like an L7 clearing like 500,000 a year and you're still Googling like how to do a for loop in Python. Like that's normal. Like that's, knowing the specific of syntax, like that's not, this isn't the 70s where you're like coding in a windowless thing. Like, yeah, being able to look things like I think for the most part that's fine. I think particularly with like they just don't want you to just vibe code the whole thing.
No,
They want to see, yeah, and I know you won't, but I think for them, like they want to see you work through the problem, solve the problem. And if you have to pull in external inputs to sort of get that there, that's, I think for the most part, that's fine. Again, as long as they're seeing like you systematically tackling the problem and demonstrating insight as you're doing it. Oh, sorry. There's a question in the chat. So Estefani, I think for this one, I think we're pretty much of a, there might be another way, but I think we're pretty much of the like mind that you're going to do string manipulation. I think, yeah, I think that's where my head went. That's where everyone else in the room's head went. I code up a solution, so I know it works. And yeah, we pretty much, first thing you do is to convert it to strings for, yeah. So I'm not saying you have to do that, but, um, that's kind of where things went. But yeah, sorry, Raymond, you got another question?
Yeah, I was just wondering, and then for
Mhm.
to get to like the optimization of solution, is
Yeah.
that kind of related to data structure and algorithms, or is that just like
That is. So that's something again, we're gonna talk a little bit more about that further on in the course. For now, it's enough to say, so when we talk about optimization, there's really two paradigms you can optimize for: storage and runtime. So storage means obviously you take up the minimum amount of memory to execute this. For most problems, that's not a huge issue, but that's an issue at scale, right? That was something Kern was sort of mentioning. When you're dealing with massive data sets and yeah, doing things like dynamic programming, those are huge, huge memory sucks. Um, and so, optimizing that's huge. Runtime is another big thing that you try to optimize for is sort of optimizing right the minimum number of sort of calls that you need to make to arrive at a solution. Huge from, performance, huge from cloud compute cost things, so there's huge things. Generally speaking, first goal, get across the finish line, get something working, pass your test cases, pass your edge cases. Generally, that's a brute force solution, but get something implemented, get it working. Once you've got that done, then it's like, okay, how can I polish this? How can I optimize? Are there different approaches, different sort of things to do? But but you don't want to, again, the old adage of the perfect being the enemy of the good. This is a timed exam. You don't need to sort of win, in the most optimal algorithm ever. Get a brute force implementation done, and if you got time, then look to optimize. So,
because
mhm,
with the solution of cutting the for loop in half instead of like how the original
mhm,
my solution was like to go through the whole length of the string.
yeah.
That pretty much like saves it like 50% because we're cutting the string in half. Because we're only comparing the first half.
Yes, although what I'd say, so it will get a little complicated. You're not wrong, right? And that's definitely an optimization. But generally, when we talk about runtime efficiency, we think in terms of orders of magnitude.
Oh.
And so what that means is we're talking about the difference between, so and we usually talk in terms of the size of the data set you're working with. And so like you hear big O notation, order of, yeah. So that's in terms of the data set. So like going from, so if the data set's n, you're going from n to n divided by two. Like that's not trivial. Like that's meaningful, but that's not an order of magnitude. When we talk about optimizations, we're talking about going from like, you know, an n squared or an n cubed runtime to like an n runtime. Like that's the sort of efficiencies that we tend to, if you're saying like, oh, my runtime is n squared plus two steps, and I reduce that down to one step because instead of doing two print statements, I'm doing one print statement. Like that's not the,
Not efficient.
yeah. I mean, don't get me wrong, it's good from a clean code perspective, but that's not the order of magnitude that we're sort of looking at.
Legal notation doesn't even disregard anything after the square. You
Yeah.
just take the biggest exponent, and that's the efficiency.
Yeah, exactly. Yeah, if it's n cubed plus n squared plus n like runtime, like it's just O of n cubed. Yeah. All right, so let me pause. Okay, and then folks in the Zoom, any other questions?
Yeah, so I asked that question because well the video recording like ended for whatever reason. Then I
Yeah.
was like on there looking, and and I did the string manipulation was the first thing I
Oh,
did. But then
cool.
when
Okay.
I was like, oh, I'm gonna read the comments and see what people are saying or like what their solutions are.
Hmm.
And like one of the top comments was something like, hey, yeah, manipulation obviously will work, but that's not what the question's asking for. And so I guess my question is like, how big of a difference does it make if you answer like for example, like my my knowledge of Python is just having taken intro to Python. So string
Yeah.
manipulation is really the only answer or solution I can offer.
Yeah.
But someone else like responded with some like pointing left, or I don't know. I don't understand what any of that language meant. But in the comments, like bottom left, there's like a little comment bubble.
Yep.
It's 116. But so someone was just saying like that's not what they're looking for or whatever. And so I was just curious, like, if you are in an interview, how big of a difference does it make? How you solve it with like the string manipulation is quick and easy and it gets you the correct answer versus someone who uses a more like complicated.
Yeah.
answer.
Yeah, and here's the unfortunate thing with this. I think, I see this comment here now. Categorized as easy, sure it's easy, blah, blah, blah. Here's the thing. It will work. It will pass all the tests. You will do exactly, the work that you're supposed to do. And for many tech companies, in fact, there's that famous adage, I think maybe it was Steve Jobs, who always said like he always hires the laziest programmers. And the whole idea is like they're the ones who will find the simplest route to a solution and will not over-engineer it. And so there may be people who will look and be like, dude, this solution was sitting in your face. You could have coded up in 5 minutes. Instead, you're getting into like, linear algebra type things. You spent like a whole thing, like why? You could have gotten this done in 5 minutes. Why am I, what am I paying you for? So like there's just as many people who would have looked at that and been like, why are you like this is passing every test. This is meaning everything. Yeah, if you want to spin your own wheels and do this, that's fine, but that's not what I'm paying you for. So, I don't want to say like every, boss will have that response to everything, but yeah. And again, this is the point that like we made earlier on. Like every coder comes with a different background and a different set of experiences. And you're going to work with the toolkit that you got. So like you said, you're coming from a thing where string manipulation, that works for you. It's something you're comfortable, you understand. You're going to get a working solution. Run with it. Don't like if it's passing the tests, if it's, objectively a good algorithm that's efficient from a runtime and storage perspective, like there's no right answer for this. And I think that whole gatekeeping that's like, oh, well, no, this was a math problem, so you need to take a mathematical approach to it. It's like, okay, well, have fun with that. Like, so yeah,
Figure that out now.
again, for some people it works. And if that's where their background is, like, good, like let them run with that, and that's fine. But yeah, so. And again, and I don't want to say like uniformly, but like every company's gonna be different. And again, just as many companies might be put off by that approach as not, because again, they'll look at this and say like we prize efficiency and we prize, productivity, and we want you to push, PRs, and we want you to get through problems quickly, which means figuring out an easy path to a solution and not, yeah. So just as many people might be put off by that kind of approach. All right, let me pause the recording there. I'm gonna give you guys some time to work it, and then we'll work the problem together. All right, crew, welcome back. So I know a few of you, how are we doing on this one? No worries. Okay. Yeah. So I'll start working out the solution. But again, one of the things I want to emphasize with this is, so a few things I want to emphasize with this. Printing out intermediates is an important thing, particularly like when you're looping, making sure like the loop is doing what you're doing is a helpful thing. So I'm not necessarily going to do that today, but one thing I would encourage is you're building out your own things, particularly when you're testing the logic of this. So like I already kind of worked and got a lot like the logic working for me, but one of the easiest ways you may mess up is you think you have an approach, you think it works, and then you test and you're like, oh wait, that didn't work at all. So printing these out, right? So in this case, like printing out your intermediate outputs, if you're looping, printing out, just making sure it's doing what you actually think it's doing. Let's see. Yeah, the other thing is just kind of writing it out And like it can be really helpful sometimes just to literally to write out your approach. Again, everyone's a little different, but sometimes doing it. And then the third thing is work through specific examples. And like Leetcode has specific test cases like you see on the bottom that like whenever you run the code, they'll do. But it's also helpful just in your own brain to sort of think through, okay, well, what is this going to look like? Like, how is this actually going to work in that? So, and like what I mean, like in this case, I think the challenge here, at least with the way we're thinking about right now, is just kind of getting the looping correct, right? And so, so before we actually sort of abstract the algorithm, let's sort of think about an actual example of this, right? So so let's sort of write out and let's make sure. Oh, am I? Okay, yeah, that's good. I don't need to share screen. Let's use an example here. Let's do 1, 2, 3, 2, 1. So that clearly is something that works. Okay. And so in this case, we know abstractly that we need, we're going to compare 0 and for our purposes, let's just use absolute index position. 1, so it's 0, 1, 2, 3, 4. 0, 4, 1, 3. And we know we don't need to worry about that middle one. In this case, for an odd one. Okay. So the first thing we're going to say is, okay, and we've sort of already talked about that. We really only need to we need to do integer division. Because, and specifically, if we take the length of this, length of our list, and integer division 2, that'll give us, like, if it's 5, the length is 5, integer division 2 is going to give us 2. Because we know the odd one out we don't need. We just need to do an even number of matches. Okay, so it's going to be that and that. And so, so for our first loop, so we know sort of our first loop is going to go, so we know we need to loop 0 and 1 and not 2, right? We don't need to do that. So length of this is going to give me that 2, but I think we actually need to do length of that minus 1, right? Because this is, so we're going to start with 0 and we're going to go to that. Right? Because remember, for range, it's on the outside. And so if this is 2, we know we need a 0, 1. Again, for me, like it helps visualize, right? It helps you to say like, okay, I know I don't need to go to index position 2. I only need to go these first 2. So that's going to be my first range for my first loop. Okay, but what about this one here? So for this one, you could do negative indexing. That's a way to do that too. For this one, I know I need the total index, total length, minus 1, right? So it's going to be total index minus 1 because length is 5, but I need index position 4. So it's total length minus that. And then the question is, okay, well, as I'm moving forward, what's the algorithm for doing that? Well, as index position goes up, this index position is going down, right? So at index position 0, that's going to be 4. Index position 1 is going to be 3, i.e. it's going to be the length minus 1. So total length minus 1, because I'm going to give, right, if it's 5, I need 4, minus index, right? Because 0, 1, 4 minus 1 gives me 3, and so on and so forth, right? So again, I think just thinking through that is probably the challenge of this. And again, it's not necessarily hard, right? It's just sort of thinking it through. And again, kind of whiteboarding or doing that equivalent, like literally having some scratch paper can sometimes be really helpful just to sort of work through and make sure like your algorithm makes sense. So okay, so let's actually code that up. Share screen. All right, so again, so the first thing we do obviously is we're going to convert this into a string. So I'm just going to say s equals str, and we're putting x as an input. All right, so now I got my little string. Okay, so I'm going to say now for I from index in range, in range. And again, we're starting at 0, so I don't need to input a thing here. Oh, I don't need to do minus 1. Sorry. don't listen to me for -1. I spoke incorrectly because it's exclusive. If the length divided by 2 is 2, then I only need 0 and 1. So I actually don't need to subtract 1. I'm sorry. Because it's exclusive, you're already by default doing that. Sorry. I misspoke. I realized that. Okay, for a range. So I don't need to put my input, I just put my output here. So it's just gonna be length of S integer division 2. All right, and so for that, and then I'm going to test, and I'm going to say, and basically so the way I'm going to structure this, so here's how I think I'm going to do this. If at any point, right, as I'm doing this loop, if at any point it fails, and by way it means it fails if it's not a match, because this is one of those things where everything has to match, right? Which means there can be nothing that doesn't match. So basically, I'm just looking for the thing that doesn't match. So if at any point it doesn't match, return false. Right, so that's going to be our loop. I'm going to loop here. I'm going to say if at any point it doesn't match, return false. If not, return true. And I don't need to do that as an explicit thing because return statement is sort of equivalent to a break statement. Because a return is essentially an ending of a function. The moment you do a return, you're basically saying, okay, end of the line, right? You don't have to code an explicit break. It's equivalent to a break. So, okay. So for I is in that thing. So now we're saying if these don't match. So if S index I is not equal to, and now we need to use our logic for here, which is length -1 minus I. So it's not equal to S of length S -1 minus I. So if that is not the right, if that returns true, in other words, if they don't match, then you return false. And then barring that, outside of the for loop, I then have a return true. Okay. So let me test this and make sure my thing is correct. Okay, cool. Passes my cases. Let me submit. Okay, cool. All right. Not particularly great in terms of runtime. Bottom 18%, but
Run it again, it could be faster.
it's true. 15 milliseconds. No, got even worse. Jeez. But basic thing here works. Okay, let me there's one thing I'm going to show you guys. Okay, actually, I see Aaron and Kern, you're actually already seeing the screen, so that's cool. There's one actually, after I did this, I thought about kind of, was there a way to do this without doing the loop? Because that was my like, okay, can I potentially beat this without doing the loop? And the basic idea was, okay, what if I just built the reverse string and then just said, are these equal? Right? So don't loop, build the reverse and do that. And how do you build the reverse? I don't know if you guys remember this, but there is a way to do that index-wise. So remember we have we have this notation where it's like start, end, increment. So this was like a little trick we sort of learned in intro, which is I could basically say R equals S start equals -1. And then just simply say if R is equivalent to S, return, say here. So let me comment this out. Oh, that's another thing, by the way. When you start messing around with this, which is good, after you optimize, don't get rid of your working solution. That's another mistake I make a lot. Don't like delete your thing. If you've still got comment out the brute force thing I mean, technically it doesn't matter because you still technically solved it, but like comment out the brute force thing and then be like, here's my opposition. Okay, return true, else return false.
You return R equals S.
Yes, you literally could. You could, and that's where I'm gonna,
Well,
that's where I'm getting next. Okay, so, okay, slightly better. But okay, so now we might say, okay, well, is there a way to optimize this further? And indeed, so Kern's already ahead of me with this. I don't need to do this like whole stored as R, do a if then branching check. So I'm gonna comment that off yet. I can literally just return the result of that logic. I.e., I can say return S, and let me show you another thing I'm going to do. Just get rid of the R, this line here. Let me just run this. But we can just condense this to 2 lines of code. Look at that. Memory I'm now up to, because look at that. I'm not doing all those unnecessary memory things, right? And I'm already at 40%. And literally, look at our little code thing here. We got down to 2 lines. So, and I'm sure we could probably take it further, but that's already getting pretty compact. But all right, crew. Any questions on that? Please.
Is it ideal to make some unoptimized decision in your code for readability and understandability? Like, let's say I do declare a Boolean variable just to make it readable. So like, I declare a Boolean called not match. And I can just say, if not match, return true, else false. So that someone that's like maybe 6 months down the line and goes bad, and I don't have to know like underlying logic to it. I could just read it kind of plain English, if that makes sense.
Yeah, I'd say probably yes, because realistically, the amount of um like the amount of memory that you'd be using by that specific variable is so small that I think making your code more readable for an end user is probably, on balance, much better. Yeah. Like generally you're not, by getting rid of, yeah, temporary, placeholder variables, things like that. Yeah, I mean, if it's a well commented code, it could also mitigate that, but yeah, I mean, but yes, at some point you do need to think beyond just making sure the code is as efficient from a computational standpoint, but also saying like, can anybody other human being possibly parse what's going on here? And so yes, that does become a very significant consideration.
I guess a quick follow-up.
Yeah.
For technical issues, technical interviews, it would just be the best code, like most efficient code, right? Like not readability is like not even a priority. Or readability is still a priority.
I think the expectation, particularly because these are timed, is that it's going to be messy. I mean, again, it doesn't hurt, but I think, it's much more important that one, your algorithm works, and two, the icing on the cake is if you can optimize the algorithm. I think readability is a distant third.
Okay.
Like, it doesn't hurt if you got it, but I certainly wouldn't be I wouldn't be exerting trying to make sure like my indents are proper and every function is properly commented and everything. Like I wouldn't, you know, that's not where I mean if you finished in 10 minutes and you're like, well, I got all this time, I guess I'll go through and clean up my code. Sure, but yeah, I'd say a distant third.
This is going back to the lecture, but
Mhm.
so
Oh yeah, Estefania, I see what you, yeah, you look at that. You made it one line. Look at that.
um is
Mhm. Oh, sorry. I think I'll stop this recording then. So, okay. That was our parallelogram comment. So, okay. Awesome conversation.